Hello class, welcome to our Consumer Math Unit 7 Lesson 2 Lesson over Triangles. So again, this is our second lesson in our geometry unit for Consumer Math. So our objective today is we're going to be able to solve problems involving angle relationships and triangles, similar triangles, and we'll solve problems involving the Pythagorean theorem. So today is Triangle Day. So going to our notes. One thing, like the most important thing I think we teach in geometry is that the sum of the measures of the three angles of any triangle add up to be 180 degrees. So with the first example here, it says, find the missing angles in the triangles. So knowing that all three angles of a triangle add up to be 180, and I'm sorry these pictures came out a little blurry. If you can't see, this is 68 degrees and this is 47 degrees. You know two angles of a triangle, you can find the third one by subtracting the two that you know from 180. Whatever's left over is your missing angle. So the measure of angle X is equal to 180 degrees minus the two angles that we know. So minus 68 and minus 47. Get out the calculator. So 180 minus 68 minus 47 gives us 65 degrees. So the measure of angle X is 65 degrees. For our second example, we have this angle is 55. That one came out a little clear. There's this box here. Whenever there's a box in an angle, that means that's a 90-degree angle. So we have 55 for this one, 90 for this one, and this is the one we're trying to find. So again, the measure of angle X is going to equal 180 degrees, because all three angles of a triangle always add up to be 180, minus the two angles that we knew. So minus 55 and minus 90. And we end up with 35 degrees for our missing angle. For example 2, says find the missing angles. So now we have a couple of triangles. We've got vertical angles and we got a linear pair. So we'll be using a little bit of what we learned last class to help us find some of these missing angles. So here, let's start from the outside and work our way through. So here we have an angle that's 130 degrees. However, that's not inside the triangle. That's this angle outside of the triangle. But what we know is when you have two angles that make a straight line, they add up to be 180 degrees. So if I take 180 minus 130, I get 50 degrees. So this angle right here of that triangle is a 50-degree angle. Now we know this angle, and if they're telling you this angle right here is 63. So we have a little triangle here where we know two of the angles. So now I can, so I'm going to say that this was my step 1 on this problem. For step 2, I'm going to take 180 degrees for the angle. So we're trying to figure out angle X right now, right? So X is equal to 180 minus 63 minus 50, because those were the other two angles of that triangle. And we get 67 degrees. So this one's 67. All right. Now, knowing that this angle right here is 63 degrees, something else we talked about last class was whenever you have two lines that intersect, I like these better. So here's one line, here's another. Whenever you have two straight lines that intersect, the angles that are opposite from each other are equal to each other. So if this angle is 63 degrees, then this angle is also 63 degrees. So for step 3, y is equal to 63 degrees because of the vertical angles theorem. If I could spell vertical. All right, so now we've got angle X, we've got angle Y. The only one we have left is angle Z. And what we see here is a second triangle where we know two of the angles now, and we're trying to find that third angle. So 180 degrees is what all three, let me pause for that. 180 degrees is what all three angles of the triangle equal. So Z equals 180, or what the three angles add up to be. So Z equals 180 minus 85 minus 63. We get 32 degrees. So now we know all the angles. So Z was 32, Y was 63, and X was 67. All right, example 3, same kind of thing, find the missing angles. And I'm sorry this picture came out blurry. So here we have this triangle. So notice how we have 1, 2, and 3, and they don't have the degree symbols with them. That means they're not saying that this angle is 1 degree and this angle is 2 degrees and that one's 3. They're calling this angle 1, angle 2, and angle 3. That's the name of the angle, not how many degrees they are. So we're going to find angle 1 first, because here we have a triangle where we know two of the angles, so we can find that third angle. So measure of angle 1 is equal to 180 degrees minus 43 minus 74. And we get 63 degrees. So there's angle 1. And anytime I figure out new information, I always put it on my diagram. That way all my information is on my diagram. All right, now just like we were talking on the last problem, I here have two straight lines intersecting each other. So these two angles, angle 1 and angle 2, are angles that are opposite of each other based on those intersecting lines. And so they're vertical angles and they're equal to each other. So that means angle 2 is also 63 degrees. And that's because of the vertical angle theorem. I think I spelled vertical wrong earlier. I had a brain fart, different kind of vertical. I'll fix that in my notes before I save them. All right, and now we have, lastly, the other triangle here. To find angle 3, we've got two angles of that triangle. We're just trying to find that third angle. So the measure of angle 3, since they all three add up to be 180, is just 180 minus 79 minus 63. And we get 38 degrees. And there you go. All right, so that's all based on the three angles of a triangle adding up to be 180 degrees. All right, so from there, something else we need to learn about triangles is we're going to talk about similar triangles. So similar triangles have the same shape, but they're different sizes. Let me make that, no. Same shape, different sizes. So because of that, angles are equal to each other. So like angle A would be congruent to angle D, angle B is congruent to E, and C is congruent to F. So like they would have the same measures. So angles are, I should say corresponding angles. Let me rewrite that. So with similar triangles, corresponding angles are equal, and sides are proportional, and corresponding sides are proportional. Sorry, that came out a little funky. But what that means is when they tell you triangle, let's say ABC is similar to triangle DEF, this is the symbol for is similar to. So triangle ABC is similar to triangle DEF. Then based on the order of the letters, those are what are corresponding with each other. So angle A corresponds with D, angle B corresponds with angle E, angle C corresponds with angle F. So remember, angles are equal to each other. The corresponding sides are proportional. And so you could set up these proportions. So proportions just mean two fractions set equal to each other. So like segment AB, that's the first two letters. Segment DE, that's the first two letters. So segment AB over segment DE is equal to BC, the last two letters, over EF, the last two letters. You just got to keep the triangles in the same position. So like triangle ABC, they put those all up top. Triangle DEF, they put those sides in the denominator. And then once you set up a proportion, you can cross multiply to solve. So we're going to go ahead and use that information to help us find missing sides. All right, so for number 4, it says find the missing sides. So again, similar triangles, and they should have told us these two triangles were similar. But these two triangles are similar, so their sides are proportional. So based on this, they've already showed you the shape is the same. So they're saying this side corresponds with that side corresponds with this one, and this one corresponds with this one. So we want to set up a proportion since the sides are proportional. When you're trying to find a side, or when you're finding a specific missing side, you got to include that in one of the proportions. Otherwise, what are you doing? So let's start with X. Let's, from this first triangle here, put X in the numerator. Since we're trying to find X, X is this bottom side of the triangle, so this is this bottom side of the triangle, so that would go over 5. Now, since we used a variable, we used the side that we're missing on this first triangle, then we got to use the side that we actually know the length of. So for our other fraction, since X came from this triangle and 6 comes from this triangle, 6 is going to go in the numerator. And then since 6 is this left-handed side, and this 12 is the left-hand side, then 12 goes in the denominator. So basically we just said X over 5 is equal to 6 over 12. And now let's cross multiply. So X times 12 gives me 12X. 5 times 6 equals 30. Now from there, I want to get X by itself. So since I have 12 times X, to get rid of the 12, I need to divide by 12. Whatever I do to one side, I do to the other. So X equals 30 divided by 12, which gives us 2.5. So X has a side length of 2.5. Now we want to find Y. So setting up a proportion again, because sides are proportional, putting Y in the numerator over 13, because that would be the corresponding side on the other triangle with it. And then again, over the side that we know, 6 over its corresponding side, which is 12. Cross multiply to solve. 12 times Y gives you 12Y. 13 times 6 is 78. And then to get Y by itself, we need to divide both sides by 12. So 78 divided by 12 gives me 6.5. So there are our two missing sides. For the next example, it says find X. So here we do have two separate triangles. They just are overlapping each other. When I work with overlapping triangles, it's probably a good idea to just draw them separately. So I'm going to redraw these. I'm not going to make them the same size, but so this is this first triangle, DEC. And then the big triangle, ABC. All right, So side DE has a length of 7. Side DC has a length of 15. Side AB has a length of 11. And for us to set up a proportion that involves x, we've got to use this side AC. Now, from here to here is x, and from here to here is 15. So that whole side length is those two pieces added together. So x plus 15. So that's the side, that's what represents the length from A to C, x plus 15. And again, we're assuming these triangles are congruent, or not congruent, but it's similar, even though they didn't tell me, they didn't say that. It's something I should have put in my notes to begin with, but I apologize. So since these triangles are similar, we can go ahead up and set a proportion to solve these. So I would say, since we have letters with these vertices of these triangles, I would say triangle ABC is similar to triangle DEC. So based on that, setting up your proportions, side AB goes with side DE. And then side DC, I'm sorry, let's go with the other one. So AC over DC. Because you want to be consistent, since AB and AC come from the same big triangle ABC, and DE and DC come from the same smaller triangle, you want to keep them in the same positions here. All right, so we basically just said that AB corresponds with DE, and AC corresponds with DC. So now let's plug in those numbers, or substitute in those numbers, and solve for x. So segment AB has a length of 11, and the reason I didn't mess with sides EC and BC is because we don't have any information on those, so we couldn't even use those anyway. So the distance from A to B is 11. The distance from D to E is 7. The distance from A to C is x plus 15. And the distance from D to C is 15. And now we just cross multiply to solve. All right, so 11 times 15 is 165. And 7 times x plus 15. When you're multiplying 7 times x plus 15, remember you have to distribute it to both of those terms. So 7 times x gives me 7x, and 7 times 15 gives me 105. Now from there, you're working towards getting those x's by themselves. So first step, subtract 105 from both sides. Because whatever you do to one side, you have to do to the other. So we're left with 7x is equal to 60. And then to get x by itself, divide by 7. You get 8.57, so I'm going to say 8.6. And there you go. So x is equal to 8.6. And again, remember, x is just this distance from here to here. That's what we figured out. All righty. So continuing on with one more question with dealing with similar triangles, here's a word problem. It says, example 6, a man who is 6 feet tall is standing 10 feet from the base of a lamppost. The man's shadow has a length of 4 feet. How tall is the lamppost? So I definitely want to draw my diagram. So we've got a lamppost. Let's say this is my lamppost. And then we've got a man. It says a man who is 6 feet tall. So think of this as a triangle. This is 6 feet. Is standing 10 feet from the base of a lamppost. So from here to here is 10 feet. The man's shadow has a length of 4 feet. I'm sorry, we'll say his head was right here. So his shadow is 4 feet. And they want to know how tall is the lamppost. So that's our variable. All right, couple things. Now we've got two similar triangles here. We've got this smaller one here, and then we've got the lamppost all the way down here, bigger triangle. So when you're setting up these problems, the important thing to keep in mind when you're setting up the proportion to find a missing side is to be consistent all the way through. So like if I do man's height we can put that over, let's say, man's shadow is equal